Cpctc. Okay, here's the deal. 4 kind of takes it to the next level with how we prove things congruent. So we have done triangles congruent and used SSS, SAS, ASA, and AAS so far, right? What we're going to do next is once we prove the triangles are congruent with one of those 4 things. What are we doing? Did you just... Sure. So once you prove triangles are congruent, then you can prove anything about them is congruent. Because what do we know about congruent triangles? That all 3 angles and all 3 sides are congruent, right? So if we can get to a point where we can say SAS is true, so this triangle is congruent to this triangle by SAS or SSS or one of the 3-letter theorems, okay? Once we know the triangles are congruent, then everything about them has to be congruent. So if I want to prove angles are congruent, I just have to take it one step further and say Cpctc, because Cpctc stands for corresponding parts of congruent triangles are congruent. Cpctc. So Cpctc. Okay? Corresponding parts, so the parts that match up of congruent triangles have to be congruent to each other. Cpctc, okay? And you may use Cpctc every time. So here's essentially what you're doing with that. If I tell you we have these 2 triangles where this is A, B, C, and this is D, E, F, and angle A is congruent to angle D, AC is congruent to DF, and angle C is congruent to angle F. Okay? Right now, I can say triangle ABC is congruent to what triangle? DEF. By what? ASA, right? Angle, side, angle. So if I know this, then I can say that, for instance, angle B has to be congruent to angle E by Cpctc, right? If I know the triangles are congruent, then I know every aspect of those triangles is congruent. So even though B and C aren't marked, okay, I can say they're congruent. We also could have said it by third angles theorem, but we could also say that AB is congruent to DE, right? Those ones aren't marked for us, but because we know the triangles are congruent, everything about them is congruent, so those are congruent by Cpctc. So it's just proving, it's taking it one step further, proving that the parts of the triangles are congruent once we've proved that the triangles themselves are congruent. Okay, so here's what we're going to do today. I'm going to give you 2 proofs. We're going to walk through so you can kind of see the flow of a Cpctc proof, and then we're done. It's a very short lesson. All right, first example. Let's say you are given, and I'll give you time to write it all out as soon as I finish this up. So RS is congruent to UT, and RT is congruent to US, and we want to prove angle T is congruent to angle S. Okay? If you have that little sheet of paper that I've been giving you little pointers on, you might want to get that out shortly, because I'm going to give you a little pointer that goes along with this. But here's your picture. This is R, S, U, and T. So I'll give you a sec here. Our first step of a proof is always what?
The given.
The given. But before you even go there, you should do what? You should mark up what you know. So if we're looking at this picture and we see RS is congruent to UT, so put little hash marks on RS and UT. And then RT is congruent to US, so I'm going to mark those here, 1, 2, and 1, 2. We're trying to prove right now that this angle is congruent to that angle, okay? My little dots. We're trying to prove those dots as angles are congruent. Here's the issue. We don't know anything about those two angles, okay? They are not corresponding. They are not alternate interior. They are not vertical. We don't know anything about them. However, we do have two triangles there, and we can prove the two triangles congruent. So our first step is always the given, right? One is given. So we would just take this information and move it here. Anyone see how we can prove the triangles are congruent, or something else about these two pictures that we know are congruent? Right. Right. Okay, so we're going to take that down a notch real quick. So RU is congruent to RU. That's the reflexive property, right? So we're going to mark these congruent. RU congruent to RU is reflexive. Okay. Now, if you look at your picture, you can see by your markings that you have side, 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 and side, side, side. What are we saying when we say SSS? What's the left side? What's going to go right here? Oops. Right here in number 3. The triangles are congruent, right? If you see SSS, it's proving triangles congruent. So we're going to say triangle, and you can name these a lot of different ways, but you have to make sure you match up corresponding parts, right? So if I start at TRU, what triangle would TRU be congruent to? SUR. Okay, so we know the two triangles are congruent, but we're not trying to prove the triangle's congruent. We're trying to prove something about the triangle's congruent, so we're trying to prove the angles are congruent. Well, now that we've said those two triangles are congruent, we can say that the angles are congruent. Angle T is congruent to angle S because they are corresponding parts of congruent triangles that are congruent. So Cpctc, okay? Here's what you should write on your little proof cheat sheet. Whenever you're doing a proof, if your prove portion, what it tells you to prove, if this is segments congruent or angles congruent, then your last step is going to be Cpctc. Okay, so if you're proving segments congruent or angles congruent, you're going to end at Cpctc. If you're proving triangles congruent, okay, so if the prove part is triangles congruent, actually here, let's write it like this. Triangle something congruent to triangle something. That's always going to be one of the 3-letter ones, which I think you wrote down at one point already. But if you want to compare, this is the difference. Okay, so if what they ask you to prove is segments are congruent or angles are congruent, you're going to end at Cpctc. If you end at triangles congruent, you're going to end at the 3 letters: SSS, SAS, ASA, AAS. Okay, Cpctc can never come before SSS, SAS, all of that. You have to prove triangles congruent first in order to use Cpctc. So it will never look like this. Cpctc is step 4 and step 5 is SSS. That just will not happen. Now, it doesn't mean that you can't do a Cpctc and then prove two different triangles congruent and do another Cpctc. That can happen. But if this is your only Cpctc and three-letter theorem in a problem, they have to be in the other order. It has to be the triangles congruent first and then your Cpctc. Does that make sense? Okay, let's do one more proof and then we're done. All right, let's say you're given RS congruent to VS, RT congruent to VU, and angle R and angle U are both right angles. Okay, and we want to prove angle T is congruent to angle U. So what do you think the last step of your proof is going to be? If we're proving angles congruent. If we're proving angles congruent, what's your last step going to be? Cpctc, okay? So you don't want to stop at SSS, SAS, all that. All right, if this is RS, V, U, and T. First thing we're going to do is mark up what we know, right? So RS is congruent to VS, so this is congruent to that. RT is congruent to VU, so those two are congruent. And then R and U are both right angles. How do you mark a right angle?
With a square.
The little box with the little square in the corner. Okay, so that's everything that we know. So our first step is going to be all of the given information. So this is all going to go here, and we call it given.
Wait, is it U supposed to be switched with U because U is the one that's the right angle?
Oh, I did write U as the right angle. It's supposed to be V. Sorry. My bad. R and V are both right angles. I wrote that wrong. Okay, so if you look at what we have here, you can probably see one of the three-letter theorems already, but technically we can't quite use it. What three-letter postulate do you see?
Side angle side.
Side angle side. Here's what we have to say. In order to use SAS, we have to know angle R is congruent to angle V. And we just say that's because all right angles are congruent. Okay, if we have two right angles, we know they're both 90. So all right angles are congruent would be your reason for that. And then you can say the triangles are congruent. So we can say triangle, if I say TRS, that's congruent to what triangle? So TRS is congruent to UVS by what? SAS, some SAS. Okay, so if we're trying to prove angle T down here is congruent to angle U, how do we know that T and U are congruent? Cpctc. So because the two triangles are congruent, then the two angles are congruent by Cpctc. Okay, so just get used to this. If you've proved triangles congruent, Cpctc is more than likely the next thing that you need to use. All right. Any questions on that? How are you feeling about proofs?